What is the chemical energy?
Potential energy of a system due to its chemical composition. A chemical change can cause this energy to be changed into or out of other forms. Animal bodies and batteries are two common objects that have chemical energy.
What is a focal length?
Measures the strength of a lens or mirror. Distance from lens or mirror to focal point.
How can you describe the path of a thrown ball?
You know what happens when a ball is dropped. It accelerates downward, gaining speed at a rate of 9.8 m/s each second.
What is a maglev?
Magnetically levitated trains that use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks.
What is a teleportation?
Communicating the state of an atom involving entangled photons.
How do clouds form?
As warm air rises into the atmosphere through convection currents. The air expands as it experiences less atmospheric pressure. During the expansion, the warm water vapor quickly cools and condenses, forming water droplets in the air. When the droplets begin to accumulate, they attach themselves to dust particles in the air and form clouds.
What is compression?
Region of higher pressure in a longitudinal wave.
What is a shadow?
Areas of darkness created by an opaque object blocking light.
What is accuracy?
How correct or how close to the accepted result or standard a measurement or calculation has been.
If two objects interact, what happens to the momentum of the other object?
According to Newton's third law, if your hand exerts a force on the ball, the ball exerts a force on your hand. Thus there must be an impulse on your hand.
Are there non-contact field type forces other than gravity?
Both the electric force between charged objects and the magnetic force between magnetized objects can be described as the force caused by an electric or magnetic field caused by one object on the charge or magnetic moment of the second object.
How did gears play a role in an ancient astronomical computer?
In the 1st century BCE, a Roman merchant ship carrying Greek treasures to Rome sank. In 1900 CE, a storm caused a party of Greek sponge divers to seek shelter on the island of Antikythera. After the storm passed, the divers, seeking sponges, found the wreck of the Roman ship. Over the next 9 months they recovered much of the treasure, including a badly corroded block the size of a telephone book. A few months later it fell apart, showing remains of bronze gears, plates covered with scales, and inscriptions in Greek. The German scientist Albert Rehm, 1871–1949, understood in 1905 that the device was an astronomical calculator. In 1959 the American historian of science Derek de Solla Price, 1922–1983, wrote a Scientific American article describing some of the details of the device and the calculations it could do. By 1974 he had described 27 gears, including the number of teeth on most. By analyzing the teeth he discovered that the ratio could describe lunar cycles known by the ancient Babylonians. The Antikythera device can predict solar and lunar eclipses, the dates of future Olympic Games, and can show the complicated motion of the moon. The precision with which the gears were made was greater than any made in the world for the next 1,000 years.
What is Pascal's principle?
A fluid, like water, exerts the same pressure in all directions.
What is the rolling friction?
The result of deformation of either the rolling object or the surface.
What is the string theory?
Proposed theory to replace the Standard Model. Each particle is a string, a tiny closed loop. Requires a 10-dimensional spacetime rather than the normal 4-dimensional one.
What is needed to create a circuit?
A circuit is a circular path through which charge can flow. So, the first requirement is a complete, unbroken conducting path. Second, there must be a source of potential difference, most often a battery. The battery provides the voltage that will produce the current in the circuit. With only a battery and wire connecting the two ends of the battery, the resistance in the circuit will be almost zero. And the amount of current will be very high. This situation is called a short circuit. The wire will become hot enough to burn you. So, for a useful circuit there must be a third element, a device with resistance. This may be a resistor, lamp, motor, etc. In terms of energy, the energy input to the circuit is the chemical energy stored in the battery. When the circuit is complete, the chemical energy becomes electrical energy in the wires. That energy is then converted to thermal energy in the resistor or lamp, or kinetic energy in the motor. The hot resistor or lamp then radiates heat and light into the environment. In our households, the battery is replaced by the electric generating station operated by the utility company. It may use the chemical energy in fossil fuels such as coal, oil, or natural gas to boil water, i.e. produce thermal energy. The steam from the boiling water then turns the generator, converting the energy to rotational kinetic energy. The generator then converts this energy of rotation into the electrical energy that is transmitted to the home. A nuclear power plant uses the nuclear energy in the nucleus of the uranium atoms to heat the water and produce steam. From that point on, the nuclear and fossil fuel power plants are essentially the same.
How does the gravitational force cause the motion of planets?
In antiquity, the planets, the name comes from the fact that they seem to wander across the sky, were assumed to have circular orbits. In order to account for the observations, their motion was thought to involve circles attached to other circles. In between 1600 and 1605, Johannes Kepler, 1571 to 1630, made careful studies of the observations of Mars made by Tycho Brahe, 1546 to 1601. He found that a circular path required Tycho's observations to be wrong by 2 minutes of arcade. 4 times the apparent size of the moon, but he knew that Tycho's work was better than that. After some 40 failed attempts, he finally discovered that the orbit could be described as an ellipse. We now know an ellipse fits the orbits of all planets, comets, and other bodies about the Sun, as well as satellites about planets. The shape of the orbit is called Kepler's first law. An ellipse is not a circle. So the gravitational force of the Sun is not always perpendicular to the motion. Therefore, the planet's speed changes as it moves around its orbit. Kepler's second law says that in equal times planets sweep out equal areas. Thus if the planet is closer to the Sun, it will move faster than it does when it is farther away. Kepler's third law was actually obtained in 1595 and was based primarily on philosophical and theological arguments. It stated that the relative sizes of the orbits of planets around the Sun could be obtained by nesting the 5 Platonic solids: the cube, tetrahedron, dodecahedron, icosahedron, and octahedron. The planets' orbits were in the spheres that circumscribed each solid. Today we state this law as the square of the period of the planet is proportional to the cube of the radius of the orbit. The proportionality constant depends on the mass of the object about which the orbit occurs and the universal gravitational constant. The law summarizes two of the properties of orbits of planets or satellites about a central star or planet.
What is a radioactive nucleus?
Unstable nucleus that emits particles in decay to another nucleus.
Who defined or developed the meter?
In 1798, French scientists determined that the meter would be measured as 1/10,000,000 th, the distance from the North Pole to the equator. After calculating this distance, scientists made a platinum iridium bar with two marks precisely 1 meter apart. This standard was used until 1960. Today the meter is defined using the second and the speed of light. 1 meter is the distance light travels in 1/299,792,458 seconds.
How does accuracy differ from precision?
Both accuracy and precision are often used interchangeably in everyday conversation. However, each has a unique meaning. Accuracy defines how correct or how close to the accepted result or standard a measurement or calculation has been. Precision describes how well the results can be reproduced. For example, a person who can repeatedly hit a bull's eye with a bow and arrow is accurate and precise. If the person's arrows all fall within a small region away from the bull's eye, then she or he is precise, but not accurate. If the person's arrows are scattered all over the target and the ground behind it, the she or he is neither precise nor accurate.
What is a lunar eclipse?
Occurs when Earth casts its shadow on the Moon. Earth must be directly between the Sun and the Moon.
On the front of many ambulances, why is the word ambulance printed backwards?
The word ambulance is printed backwards, left and right reversed. So that when viewed in a mirror, specifically, the rear view mirror of a car, it will appear correctly, that is, forwards, ensuring that the driver can read it and respond as quickly as possible.
Who invented the first telescope?
There are a number of conflicting claims for the first person to combine two lenses to see things far away as if they were nearby. The Dutch eyeglass makers Hans Lippershey, Zacharias Janssen, and Jacob Matthias were some of the first. Lippershey described the design and applied for a patent on October 8, 1608, but was turned down. Copies of Lippershey's device, which was constructed from a convex and a concave lens and had a magnifying power of 3, were common in the Netherlands that year. Galileo, 1564–1642, heard about the invention in June 1609, in Venice. By the next day he had figured out how it worked, and as soon as he returned home to Padua he constructed one. A few days later he demonstrated it to the leaders in Venice, who in return awarded him a lifetime position at the university in Padua. Over the next year Galileo improved his instruments, and in 1610, using a telescope with a magnifying power of 33, he discovered the moons of Jupiter, the rotation of the Sun, phases of Venus, spots on the Sun, and mountains on the Moon. The Galilean telescope with convex and concave lenses produces an upright image. Based on the ideas of astronomers Johannes Kepler, 1571–1630, and Christoph Scheiner. The telescope was improved by using two convex lenses separated by a distance equal to the sum of their focal lengths. Such a telescope inverts the image. To achieve high magnifications, one of the focal lengths had to be very large. Refracting telescopes proved to be cumbersome and difficult to use. The prism-like shape of the lenses introduced colors into the images that weren't there. This defect, called chromatic aberration, was eliminated 120 years later using a lens made of a combination of two glasses. But this invention did not stop the weight of the large lens from causing it to sag, creating distorted images. Reflecting telescopes that use mirrors to focus light were invented by Isaac Newton, 1642–1727, in 1668. Today, telescopes, both refractors and reflectors, are relatively cheap. The average person can set one up in his or her backyard and gaze up at the heavens with much better equipment than Galileo or Newton ever dreamed possible.
What is a torsional force?
Force exerted to twist an object.
Does a gas or a liquid exert a friction-like force?
If you stick your hand out of the window of a moving car, you can explore the properties of air drag. The faster you go, the stronger the force. If your palm is facing up or down, the drag is much smaller than when your palm faces forward or backward, showing that the shape of the object matters. A smaller hand experiences less drag than a larger one. So, drag depends on velocity, area, shape, and the density of the air. These properties are different from other contact friction forces. But the force is still exerted in the direction opposite motion, so it slows down the object. Liquids exert similar, but stronger, drag forces.
What is a Lorentz force law?
Force on a current-carrying wire in a magnetic field. Proportional to the current, the magnetic field, and the length of the wire. Force is perpendicular to both the current and the magnetic field, and is strongest when the current and field are at right angles.
What is a gamma ray?
High-energy photons emitted by some radioactive nuclei.
What is the charge and mass of an electron?
The charge of an electron is minus 1.602 x 1019 c, coulombs. Its mass is 9.11 x 1031 kg. Both values are known to 85 parts per billion. The electron has mass, but no size. If you direct beams of very fast, high-energy particles at electrons, they are deflected by the 1/r2 force between two charges no matter how close they come. If the electron had a finite radius, then when the incoming particle penetrated the electron, the deflection would be different.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What is thermal energy?
Thermal energy is the random kinetic energy of the moving atoms and molecules that make up matter. But objects expand when heated, so the bonds holding the atoms together stretch. That means they have more elastic energy. So thermal energy is the sum of the kinetic and elastic energy of the atoms and molecules, and the bonds that hold them together. It is energy that is inside the object, and so it is called a form of internal energy.
When swimming underwater, Why is vision blurred when you open your eyes, but clear when wearing swimming goggles?
Although the eye's lens changes shape to focus images on the retina, most of the refraction of light takes place during light's transition from air to the cornea. When water is substituted for air, the angles through which light is refracted is reduced, producing a blurred image on the retina.
What is neutrino oscillation?
Change of neutrinos from one flavor to another, that is a proposed solution to deficit of neutrinos emitted by sun.
What is a gold alloys?
"24-karat gold is pure gold. 18-karat gold has 18 parts gold and 6 parts other metals. 10-karat gold has 10 parts gold and 14 parts other metals.
How is a second measured?
Atomic clocks are the most precise devices to measure time. Atomic clocks such as rubidium, hydrogen, and cesium clocks are used by scientists and engineers. When computing distances with global positioning systems, GPS, measuring the rotation of Earth. Precisely knowing the positions of artificial satellites, and imaging stars and galaxies. The clock that is used as the standard for the second is the cesium-133 atomic clock. The measurement of the second is defined as the time it takes for 9,192,631. 770 periods of microwave radiation that result from the transfer of the cesium-133 atom between lower energy and higher energy states. The second is currently known to a precision of 5 × 10⁻16, or 1 second in 60 million years.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
What is polarized light?
Light is an electromagnetic wave that consists of an oscillating electric field and an oscillating magnetic field. The two fields are perpendicular to each other. In most cases, the direction of the electric field has no preferred direction because different parts of the source produce light with electric fields in different directions. Such light is unpolarized. Some sources, however, like laser pointers, emit light whose electric field is always in one direction. Such light is called polarized.
Will more nuclear power plants be built?
Concerns over the buildup of greenhouse gases and the environmental problems caused by coal mining has led to renewed interest in building new nuclear power plants. Advocates of construction point out that if a standardized plant could be designed, then licensing delays could be reduced and design costs minimized. In addition, several new types of plants have been suggested and undergone small-scale testing. These promise to be simpler and safer than traditional designs. While recycling nuclear fuel is an attractive option, the plutonium in used fuel rods raises issues of nuclear weapon proliferation. The problem of long-term storage of nuclear waste still needs to be solved.
What is the relationship between frequency and period?
Frequency, F, is how many cycles of an oscillation occur per second and is measured in cycles per second or hertz, hertz. The period of a wave, T, is the amount of time it takes a wave to vibrate one full cycle. These two terms are inversely proportional to each other, F equals 1/T and T equals 1/F. For example, if a wave takes 1 second to oscillate up and down, the period of the wave is 1 second. The frequency is the reciprocal of that, 1 cycle/sec, because only one cycle occurred in a second. If, however, a wave took half a second to oscillate up and down, the period of that wave would be 0.5 seconds. And the frequency would be the reciprocal, or 2 cycles per second. So, you see that a wave with a long period has a low frequency, while a wave with a short period has a high frequency.
What is a monopole?
Isolated north or south poles. Predicted by some theories, but never found.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
Have you ever seen the bed of nails demonstration?
A large number of nails are pounded into a board that is about the size of a person's back. The person very carefully lies on the bed. Sometimes a second bed is placed on his chest. A concrete block is put on this bed and a sledgehammer is used to shatter the block. The person is not harmed.
What is a light detector?
converts light energy to another form of energy.
What is the Snell's law of refraction?
Describes how light behaves at a boundary between two different media.
Why shouldn't you stand under a large tree during a thunderstorm?
During thunderstorms, many people stand under trees in an effort to stay dry. However, this can have dire consequences. In the spring of 1991, a lacrosse game at a Washington, D.C. high school was postponed after lightning was observed in the sky. Over a dozen spectators ran for shelter under a tall tree to protect themselves from the rain. A few seconds later, lightning struck the tree, injuring 22 people and killing a 15-year-old student.
What is color blindness?
An inability to see some colors due to an inherited condition.
Can fusion be used for peaceful purposes?
The energy released in a fusion reaction could be captured and converted into electrical energy. The difficulty in creating a fusion reactor is confining the reactants. Typically deuterium and tritium nuclei, at temperatures needed for fusion. There are two approaches, magnetic and inertial confinement. Most effort has gone into magnetic confinement where the positively charged nuclei are trapped in evacuated regions containing strong magnetic fields that keep the nuclei from colliding with the metallic walls of the equipment. The swarms of charged nuclei, a plasma, must then be raised to very high temperatures and held at that temperature long enough for fusion to take place. So there are three variables: number of nuclei, their energy or temperature, and the confinement time. The product of these three variables determines whether or not fusion will occur.
What is the difference between speed and velocity?
Just as you can add direction to a change in position and end up with displacement, you can also specify the direction of motion. The combination of speed with direction is called velocity. Velocity is the displacement divided by the time required to make the change, or the time rate of change of displacement. Velocity is a vector quantity, like displacement. You might walk at 4 miles per hour north, or a balloon might move at 5 feet per second up. If you assign the variable x to represent north/south, y to east/west, and z to up/down position, then both the change in position and speed would be positive for movement to the north, east, or up. Your walking velocity would be plus 4x mph. The balloons would be plus 5z. Foot/s average speed is almost always more useful than average velocity. For example, in a NASCAR race the starting and finish lines are in the same position. So, no matter how fast the cars go, their average velocity is zero because the beginning and ending positions are the same. Instantaneous velocity, however, is more useful than instantaneous speed, as will be shown shortly.
What is a ground fault interrupter, GFI?
Detects difference in current into and out of circuit to protect against accidental grounding, typically through water.
Who won the Nobel Prize for their work in superconductivity?
Three American physicists, John Bardeen, Leon N. Cooper, and John R. Schrieffer, explained why superconductivity occurs in metals and alloys. Their development of the BCS theory for superconductivity was cited when they won the Nobel Prize in 1972. 15 years later, two other physicists won the Nobel Prize for discovering superconductive materials that achieved zero resistance at temperatures thought to be too high for superconductors. Physicists George Bednorz and Alex Muller of IBM found that a ceramic substance called lanthanum barium copper oxide became a superconductor at 35 kelvins.
How does gravity cause tides?
As someone who lives near an ocean will know, there are two high tides and two low tides each day. They're not at the same time each day, but depend on the phase of the moon. The heights of the tides vary over the seasons as well.
How is the gravitational field related to force?
As was described above, the force of gravity on an object is equal to the object's mass times the gravitational field strength, expressed as F equals mg. Thus if you have a mass of 70 kilograms, 154 pounds, the force of gravity on you is 686 newtons. Mass has been defined both in terms of acceleration and gravitational force.
What is a plasma physics?
Study of the properties of large numbers of electrically charged atoms.
What is speed, v?
Distance moved divided by the time needed to move, scalar.
What is a impedance matching device?
Placed between two media to create a smooth impedance transition. To maximize energy transfer by the wave through the interface. A transformer.
How does a Leyden jar work?
A Leyden jar is an insulating container with conductors on the inner and outer surfaces. When charging the Leyden jar, the source of charge is connected to a rod, touching the inner conductor while the outer conductor is connected to ground. The inner and outer conductors become oppositely charged. It takes energy to move additional charges to the jar as the charges overcome the repulsive forces of the charges already on the conductors. The jar stores this electrical energy. If the inner and outer conductors are connected by a wire, the charges flow and make the two conductors neutral again. The modern capacitor is an updated version of the Leyden jar consisting of two conductors and an insulator.
What is temperature?
Temperature is a quantitative measure of hotness. In many substances, temperature is proportional to the thermal energy in the object. But the relationship between temperature and energy depends on many factors.
Did physicists recognize the military uses of fission?
Lisa Meitner had recognized that extra neutrons could produce a chain reaction that would produce a very large amount of energy. In early 1939, physicists from many countries attempted to create such chain reactions by slowing down the released neutrons. Among these were Enrico Fermi and a Hungarian-born physicist, Leo Szilard. They saw signs that such a reaction had occurred. In August 1939, Szilard drafted a letter to President Franklin D. Roosevelt, 1882–1945, that the German results could lead to an extremely powerful new weapon. To give his letter more weight, he convinced Einstein to sign the letter. It worked. Roosevelt directed the government to support fission research and created the Uranium Committee. While there were several important studies during the next 3 years, it was the British who made the breakthrough, finding that the rare isotope uranium-235 could be used in a weapon. The Americans were informed but ignored the results until a personal visit by one of the British team members convinced the Uranium Committee of the need for action. The United States then established a new office that could authorize large-scale engineering projects enriched in uranium-235 created a need for enrichment plants. One method chosen had been developed in California. Uranium metal would be evaporated in a vacuum. The atoms went through a narrow slit and then into a region with a strong magnetic field. Because of their mass difference, the two isotopes followed slightly different paths. The atoms condensed on the surfaces of separate containers. Dozens of giant machines, called calotrons, were built in a plant in Oak Ridge, Tennessee. Chosen because abundant electricity was available from the nearby hydroelectric plants. Not enough copper was available to wind the coils for the magnets, so 70,000 pounds of silver bullion were borrowed from the U.S. Treasury to be formed into wires for the machines. Somewhat enriched uranium from the calotrons was then combined with fluorine to produce the gas U6. Because of the mass difference of the two isotopes, 235U6 would diffuse through porous membranes slightly faster, about 0.5%, than its more massive counterpart. Thousands of separations were needed to produce weapons-grade uranium, 85 to 90% 235U. The plant at Oak Ridge, built to accomplish this gaseous diffusion, had an area of 2 million square feet. Employed 12,000 workers, and cost the equivalent of $6.2 billion in 1999 dollars. At one time it consumed 17% of all the electricity produced in the United States, more than New York City.
Why is a car often the best place to be when lightning strikes?
It is not because of the rubber tires. Many people think the rubber tires of a car provide insulation from the lightning striking the ground.
How do metal detectors work?
Built into the frame of a metal detector are coils of wire that carry a current. When metal is close to the coils, the magnetic properties of the metal change the current in the coils of wire that is detected by the electronic circuits in the detector. When you walk through a metal detector with metal anywhere on your person, that metal changes the current in the coils in the frame of the detector.
What is rotational kinetic energy?
Equivalent of kinetic energy for rotational motion.
What is a Bose-Einstein condensate?
Quantum effects on a macroscopic scale exhibited by extremely cold gas of atoms. Boson particles like photons and gluons with integral spin.
What would happen if the same ball rolled off a table?
To answer this question you should define a coordinate system. One axis points down, the other, perpendicular to the first. Points in the horizontal direction of the rolling ball. The force of gravity acts in the downward direction, causing the ball to accelerate downward. But there is no force in the horizontal direction, so the ball's horizontal speed would not change. Because only the downward acceleration affects its fall. It would hit the ground at the same time that a dropped ball would. The path the ball takes is a parabola. Galileo's principle of relativity, not Einstein's, can help you understand this result. Galileo imagined a sailor dropping a ball from a high mast on a moving sailboat. The sailor would see the ball drop straight down. But an observer on the shore would see the ball having a horizontal velocity equal to the velocity of the boat. Therefore this observer would see the ball's parabolic path. But both would agree when the ball hit the deck of the boat at the same time. Galileo said that the laws of physics are independent of relative motion. This statement is called the principle of relativity.
What is acoustics?
Acoustics is the branch of physics that deals with the science of sound. Although sound has been studied since Galileo, 1564 to 1642, made some predictions in the early 1600s. The ability to study sound has grown tremendously in the past few decades because of the advent of electronic sound generators and measuring devices. In addition to the study of sound itself, the field of acoustics has several applied subfields. The most important being speech and hearing, architectural acoustics, and musical acoustics.
What class lever is a can or bottle opener?
Locate the pivot point and compare to the three drawings above. Your forearm is a lever, with the elbow joint being the pivot.
What is the principle of superposition?
When two waves overlap they don't crash and destroy one another. Instead, they pass through each other without interaction. The graphs below show two waves approaching, overlapping, and moving away. They continue to move at the same velocity throughout. The arrows show their motions. The dotted drawings show the individual waves while the solid drawings show the resultants. The amplitudes of the two waves add together, producing either a larger wave if they are both positive or both negative. They produce a smaller wave if one is positive and the other negative. In fact, as shown, they can produce no amplitude at all. The large amplitudes are called constructive interference. The reduced amplitudes are called destructive interference.
How else is friction useful in accelerating things? How do you walk or run?
Your feet are also interacting with the ground. As long as there is sufficient friction, when you push your feet backwards, the ground pushes you forward.
What is overtone?
Mode of vibration R is not a whole number multiple of the fundamental frequency.
Does light interact with an atom as a wave or a particle?
A wave carries energy continuously over time. The more energy in the wave, the faster the energy is transferred. A particle, on the other hand, delivers its energy all at once. When an atom either absorbs or emits light, the transfer is almost instantaneous. Therefore, light interacts with an atom like a particle. The idea that light comes in packets of energy was first stated by Albert Einstein. 1879 to 1955, in 1905. He called the packet a light quantum. The quantum was given the name photon in 1926. The photon has no mass or charge, but it does carry angular momentum. It always moves at the speed of light, c. Each photon carries an amount of energy E equals hf, where f is its frequency. Therefore, a photon of blue light has more energy than one of red light. The energy carried by a beam of light depends both on the frequency and the number of photons per second leaving the source.
What is the Doppler effect?
The Doppler effect is the change in frequency of a wave that results from an object's changing position relative to an observer. A well-known example of the Doppler effect is when an ambulance zooms by you and makes a wee-yo sound. The high-pitched wee is caused by sound waves that are bunched together. Because the ambulance is moving in the same direction as the emitting sound waves, the bunching together of sound waves creates an increase in the frequency and results in a higher pitch sound. The low-pitched yo sound occurs when the vehicle moves away from the propagation of the sound wave. Since the ambulance moves away from the sound wave, the spacing between successive waves becomes greater. This decrease in the frequency of the sound wave results in a lower pitch.
Why does the gravitational field depend on the distance from its center?
This is not an easy question to answer. Newton recognized the problem and had to develop a new mathematics, the integral calculus, to solve it. His argument, simplified, can be illustrated with a wooden button. Hold it at arm's length in front of a window so you can see a tree. Note how much area the button covers on the tree. According to Newton, assuming that the button and tree were made of the same material, the force of attraction of the button on you is exactly the same as that of the part of the tree the button covers. The reason is that the effect of the button being closer is balanced by the much larger mass of the International Space Station orbits at about 320 kilometers above Earth's surface.
What is a Faraday cage?
Cage or metal grating that can shield electrical charge by gathering charges on outer shell of the cage.
What is a fuse?
Protects household electrical circuits are protected by fuses or circuit breakers. Opens when current exceeds a predetermined limit.
What is a thermostat?
A device that is part of a system that maintains a constant temperature.
What is an aneroid barometer?
Device to measure gas pressure in which the elastic top of an extremely low pressure drum is bent by the pressure.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
What is latent heat of fusion?
Energy involved in change from solid to liquid phase.
What is a pitch?
Like loudness, a description of how the ear and brain interpret sound frequency.
How are gears used today?
In addition to automobiles and clocks, gears are used in washing machines, electric mixers, and can openers. And electric drills, as well as hard drives and CD/DVD drives in computers. Today much of the development of gears is associated with improvements in the materials used. New metal alloys increase the lifetime of gears used in automobiles and industries. Consumer electronics uses plastic gears that require no lubricant and are quiet.
What is Newton's second law?
If a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnet/m or Fnet equals ma.
How much water does a ship need in order to float?
Not a lot of water is needed to keep a ship afloat. Just enough so that it can displace enough water to equal its weight. Therefore, if a ship were to enter a canal that was just a bit larger than the size of the ship's hull, it would float as long as there was a small film of water around the entire hull of the ship.
What is condensation?
Change from vapor to liquid on a cold object.
What causes red eye in photographs?
Red eye occurs when a flash is used because there is not enough light for a good exposure. Under normal conditions, in order for enough light to enter the eye, the pupil dilates. But when a flash is fired, the pupils are not expecting the bright light and do not have a chance to constrict. As a result, a large amount of light enters the eye and reflects off the blood vessels that supply the retina in the back of the eye. The redness on the pupil is actually the reflection off these blood vessels captured by the camera. Camera lenses are similar to human eyes in that both have lenses that focus images onto a surface. But camera lenses are not flexible like an eye lens.
What is an electromagnet?
Coil of current carrying wire wound on an iron core that produces a magnetic field that depends on the current.
What is a cornea?
A transparent membrane that contains the fluid in the eye.
What are fusion weapons?
Even before the nuclear bomb was completed, some physicists at Los Alamos started work on what they called the super, a weapon based on fusion. After the war was over, there were heated discussions, both scientific and political, about the wisdom of developing a new, even more destructive weapon. Due to tensions in the Cold War, both the United States and the Soviet Union embarked on programs to create these weapons, informally called hydrogen bombs. The United States tested such a weapon in 1952, the Soviet Union in 1955. Britain, China, and France are known to have tested fusion bombs. Some aspects of fusion weapons are known while others are still secret. What is known is that the bomb starts with a uranium or plutonium implosion bomb with deuterium and tritium gases inside its core. The neutrons released by the fusion increase the fission of plutonium or uranium, boosting the efficiency of the fission device. The energy released is transferred to a lithium dihydride fusion fuel in a process that remains secret. That undergoes fusion, and the energy released causes fission in a surrounding layer of natural uranium. The Soviet Union exploded a fusion weapon that released the equivalent of 50 million tons of TNT. The most recent effort on weapons development is to decrease the size of the weapons so they can be deployed in smaller delivery rockets.
Why is a wedge like an inclined plane?
A knife is one example of a wedge. Look carefully at the sharp edge of a kitchen knife. It looks like two inclined planes put back to back. As the knife blade moves down through food, the wedge pushes the pieces apart. A hatchet or axe is another example of a wedge. Wedges are also used to split wood. In this case, the flat end of an axe is often used to drive the wedge into the end of a log, which is then forced apart. Wedges are inefficient machines because there is usually a large amount of friction between the wedge and the material, which leads to increased temperature of both the material and wedge, and thus heat transfer.
What is the boiling point?
Temperature at which pressure of the water vapor equals the atmospheric pressure.
What is a diverging lens?
Has at least one concave side. The shape of the lens causes the entering light rays to spread apart when they leave the lens.
Why is helium used inside airships instead of hydrogen? Isn't hydrogen more buoyant?
Although hydrogen is twice as buoyant as helium, and would be more effective in lifting an airship off the ground, hydrogen gas is extremely dangerous. The German airship, or Zeppelin, the Hindenburg, the world's largest airship at the time, was destroyed on May 6, 1937, in Lakehurst, New Jersey, when it exploded into a huge fireball while attempting to land. 36 people died in the explosion. In 1937, the United States was about the only source of helium in the world, mostly from one gas well in Texas. The Nazis wanted to buy helium for their Zeppelins. But the United States refused to sell it to them as it was considered a strategic resource. Helium is formed from the radioactive decay of uranium and thorium in rocks. It is used today to cool devices and make them superconductive. As a result, the amount of helium available is rapidly decreasing.
What is steel?
An alloy of iron and a small amount of carbon. Other metals may be added.
What is a gluon?
Eight different massless particles that carry the color force that holds quarks together.
What is a magnetic field?
Region around a magnet that causes forces on magnetic materials or other magnets.
What are streamlines?
Streamlines are lines that represent the flow of a fluid around an object or through another fluid. Streamlines are often made visible by putting thin films of smoke in the air. They are used in wind tunnel testing of airfoils, wings, and automobiles. A wind tunnel is a closed chamber with vents in the front and rear of the tunnel that allow wind and the streams of smoke that make streamlines visible to pass around an object. If the streamline smoke appears to be flowing in a gentle pattern without breaking up, then the object is considered aerodynamic. If the smoke breaks up upon encountering sections of an object, the flow has become turbulent. If the flow is turbulent, the drag may be increased.
What is a position?
The location of an object requires a reference location, vector.